I am Srimati A.J. Patil. In last video, we learned how to construct tangents to circle in geometric construction. Now here we are learning about the examples in problem set 4 of geometric construction. The first question is that select the correct alternative for each of the following question. First example, the number of tangents that can be drawn to a circle at a point on the circle, and we already know if suppose this is a circle and any point on it we can draw only one tangent, and that's why first is the answer. The maximum number of tangents that can be drawn to a circle from a point outside it, this construction already we had done. Here like this way there are two tangents from a point outside it, and that's why this is the answer. If triangle ABC similar triangle PQR and AB as to PQ is equal to 7 as to pi, then obviously this ratio is greater than 1, means 7 parts are more as compared to 5 parts. This way, therefore this AB side greater compared to PQ means triangle ABC is greater. That is the answer. Now question number 2. Draw a circle of radius 3.5, take point P at a distance 5.7 from the center, and we have to draw tangents to the circle from point P. See here, this is the example. The radius of tangent radius is given as 3.5, means we have to take distance of 3.5 in compass. Taking 3.5 as distance, we construct this circle first. Then the point center is O. Point P is at a distance 5.7 from it. Taking scale with accurate measure, this is the 5.7 distance, and this point is P. Now we have to construct tangent from P. For that, first we bisect segment OP like this way. Already we had done in previous videos. This is the perpendicular bisector, and after that we draw that perpendicular bisector. This is foot of perpendicular. Taking M as center, MP as radius, we obtain two arcs here. Suppose that points are A and B. This is A and this is B, and when we join that PB and PA, we obtain that tangents. Means here line PA and line PB are the tangents. Next example, question number 3. Draw any circle, take any point A on it and construct tangent at A without using center. Suppose this is the circle of any radius. We are taken here point A. We have to draw tangent through A. For that, take any 2 points without using center. Draw these chords. After that, we have to draw angle congruent to angle CBA, taking vertex A. For that, using compass, first of all, we draw this arc with same radius. Taking A as center, we construct this arc. Then by measuring this, putting here LO, we construct this arc, and this point of intersection and point A, that forms a tangent at point A without using center. Now the fourth point, draw a circle of diameter 6.4. Take point R at a distance equal to its diameter from the center. Draw tangent from point R. First of all, diameter is 6.4 centimeter given, means there are two methods. Either you can find out radius, and that radius will be 3.2, or using perpendicular bisector property, first draw 6.4 centimeter, this is the diameter. We have to find out its center, means by perpendicular bisector of this we can find out center. And when this perpendicular bisector, this point will be the center of that circle. Like this way we draw that circle, then this is our required circle. Now if suppose this is the center O, and what is given, from point O we have to take point R at a distance 6.4 from the center. From this we take here 6.4 distance, and now this point is R. Now we have to construct again the perpendicular bisector of OR, as we learn how to draw tangent from external point of circle. This is the perpendicular bisector, as it is twice of radius, distance is twice of radius, means that point lie on circle. Now taking this MO or MR as radius, either construct total circle or simply draw arcs here. And when we join that point, suppose this is point A, this is point B, this RA will be the tangent and RB is another tangent to the circle. And remember that these both tangent segments are of equal length. Now the example number 4. What is example number? Example number 5. Draw a circle with center P. Draw an arc AB of 100 degree. Measure 100 degree measure. Draw tangents to the circle at point P. For that, first of all, we take here as a rough figure. This is the circle. This arc AB of 100 degree. Suppose O will be the center. Then as this arc is 100, measure of angle AOB also 100, means we can write here measure of arc AB is equal to 100. Therefore measure of angle AOB is equal to 100, and therefore we can construct now tangents at A and B like this way. This is rough figure. Here we can mention rough figure. Now we construct the we have to draw first circle of any radius, because radius is not given. This is the O center. Taking any one of radius for reference. This is the suppose A point. Using protractor we can measure 100 degree at O. We have to measure 100 degree. This is the 100 degree. After that we join that in this angle. Again I repeat here, 90, and this will be 100. This point is B, means this angle is now 100 and this arc AB is 100. Now we have to construct tangents at A and B using our first method, tangent at a point on the circle with using center, like this way. Draw arcs to both sides of that point. Now bisect this segment. This is first tangent at point A. Same way, draw here bisector of obtained segment, and this point join to perpendicular point B. We will obtain another tangent. This tangent is L and this tangent is M. means L is the tangent at point A and M is the tangent at point B. This is question number 5. Now see question number 6. Draw a circle of radius 3.4 cm and center E. For that we also describe here by rough figure. This is the circle of required radius, center E. Take a point F on the circle. This will be F, suppose. Another point A such that EFA means we have to draw A onward such that this FA distance is 4.1 cm and this radius already we had given 3.4 cm. And now we have to draw tangents through this point A. These will be the tangents, and this is also rough figure. And according to this rough figure, we can construct now fair figure. The radius given is 3.4 cm. Now we start the figure. Radius is 3.4. We draw that radius 3.4 cm. Circle is here. Center is E. We join that center on point on the circle, which will be F, and from this F onward we have to take the point at a distance 4.1, means this point will be like this way, 4.1, or you may take the sum of both. This is the distance 4.1 and this point is A. Now as usual we have to draw perpendicular bisector of this segment EA first. For that, taking more than half distance, obtain perpendicular bisector of segment FA. Taking this foot of perpendicular as M, A as radius, we obtain two arcs intersecting to our circle with that radius, and these points are suppose X and Y other than AB. We can take any alphabet. This point A joined to X and point A through Y, means line AX and line AY are the tangents to the circle from point A. And this is question number 6. Now we are constructing the next question, that is our similar triangle. What is the question given? Triangle ABC, similar triangle LBN. Here also this vertex B is common. Vertex B is common. Now what is given? ABC triangle is given. AC upon LN is 4 upon 7. Means triangle ABC is smaller and LBN is larger. As this ratio is less than 1, or we may write it like this way, AC upon LN is equal to 4 upon 7. That's why AC is equal to 4 upon 7 LN. Therefore, AC less than LN. Next one means first we decide which triangle is smaller and then try to draw rough figure. Here vertex B is common. That's why take this BC as base for our convenience. This is rough figure. Here we take BC base, which is here 4.8. It is also rough figure, therefore mention here rough figure. After that, angle P 40 degree, we draw this angle as 40 degree. AB as 5.1, means here we obtain point A as 5.1 distance. This is the required triangle. Now onward, BC, this side BC is similar to triangle BN. Means onward there is a point N such that this total BN is 7 parts whereas BC having 4 parts. Means as this BN is 7, BN is 7 and BC is 4, means remaining CN that having 3 parts of that ratio. Means here we have to divide this BC as 4 and CN as 3 parts. Then after this we draw a point by constructing, and that point will be L here. Now using this rough figure we are drawing now the fair figure, final figure. For that first we construct triangle ABC. This is the triangle ABC. BC is 4.8. Here we construct that BC as 4.8 centimeter. BC 4.8 centimeter. After that we are measuring angle B as 40 degree. This is angle B, 40 degree. It is 40 degree. On this ray we have to construct 5.1 centimeter arc to obtain point A. We have to measure distance of 5.1 like this way. Taking B as center we obtain this point, and this is the point A, and this is 5.1 centimeter. Now we have to construct the BC as 4 part and another point C at 3 parts. For that we already learned how to divide the given segment in the given ratio. Here we made this ray making acute angle at vertex B. Now we have to make 7 parts using proper distance from this point B. 1, 2, 3, 4, 5, 6 and 7. We may increase this onward the ray. This is B1, B2, B3, B4, B5 and B6 and B7. Now this BC having 4 parts, that's why join this B4 to this point C. Draw a ray BC onward. Now we have to construct angle congruent to this angle at point B7 like this way. We already learned how to construct angle congruent to given angle with the help of compass. These are 2 arcs with same measure. Now this is the distance between these 2 points. We obtain here this point, and when we join that point of intersection and this point, this is the N point. These 2 line segment must be parallel. Same way we construct angle congruent to this angle at vertex N like this way. If we accurate draw this angle, then our figure is totally correct. And always remember, for construction to obtain full score, it is necessary to measure accurately. And this is the point L, and this triangle LBN is required triangle, and triangle ABC is given triangle. Same way we solve question number last, that is 8. Question is that construct triangle PYQ such that PY 6.3, YQ 7.2, PQ 5.8, YZ YZ upon YQ 6/5, and it is given that XYZ similar to triangle PYQ. Here we write triangle XYZ similar to triangle PYQ. this yz side is greater as compared to yq. Therefore that we write here yz upon yq is equal to 6 upon 5. That's why yz is equal to 6 upon 5 yq, means yz greater than yq, and yz is the side of xyz. That's why triangle xyz is greater as compared to triangle pyq. And here we obtain triangle pyq first. The measures are given as pyq. We draw that figure, first rough figure. Suppose this is the triangle pyq. As sides are given, we have to take only sides. The segment yq, because y is common in both, that's why here we take yq, and this will be p. Yq side is 7.2, pq side that is 5.8, py side 6.3. Here what is given, yz upon yq is 6 upon 5. Yz upon yq is 6 upon 5, means triangle xyz is larger compared to triangle pyq, and that's why we have to take onward this point. This yq is smaller and yz is greater. That's why here will be z. When we increase this side, py is smaller and xy is greater, means here will be the point x, and we have to draw the triangle like this way. As this ratio is 6 upon 5, this yq having 5 parts, and this total yz having 6 parts of that ratio, means this qz having only 1 part, means we have to obtain yq as 5 parts and qz as 1 part, means the ray which we divide, that is in the 6 congruent parts. Total 6 congruent parts. Out of that, q is at a distance 5 from that point. For that we are starting now the figure. First of all we construct pyq triangle. Yq is 7.2. Triangle will be much bigger, that's why construct properly, having some proper space. This is y, this is q, it is 7.2 centimeter. After that, taking compass, we have to measure 6.3. Taking y as center, we draw this arc. Now this is 5.3. Draw arc much greater because 5.3 must intersect it. Now this is the 5.3 distance. Again we can check it. It is at a distance 6.3. Okay, means our distance is correct. This is the required triangle pyq. We mentioned that figure lengths of sides. This is point P and this is 6.3 centimeter. Now onward we have to increase the ray yq and ray yp to obtain the points of another triangle. For next step we have to draw an acute angle making ray like this way. Suppose that is ya ray. Now here we have to make totally 6 parts. That's why with proper distance draw 6 arcs on this ray. 1, 2, 3, 4, 5 and 6. We can name that y1, y2, y3, y4, y5 and y6. Out of that, this is the 5 parts, means we have to join this y phi to q. And now we have to obtain angle congruent to this angle at vertex y6. For that we can draw that angle congruent to that angle like this way. For our convenience, take much greater distance. Now this is the angle. Like this way we can obtain this arc, and when we draw a segment passing through y6 and point of intersection, this point obtained here intersecting ray yq, that is z. Now here again we are constructing angle congruent to angle pqy like this way at vertex z. Again we measure this distance, and when we draw a segment passing through z and point of intersection, we obtain the another vertex of further triangle. This is the point obtained here x, and this triangle xyz is required triangle, which is similar to triangle pyq. Here our problem set 4 ends. Next chapter you can see in next video.